To show me, yeah, there we go. Show me perpendicular.
Intersecting.
Yeah, they intersect. What kind of angles do they make? Yes. So whenever you have perpendicular lines, they look kind of like just the regular graph that we make. Can those two lines have the same slope?
No.
No. So here's what you got to know about perpendicular. That they have opposite inverse slopes.
What does that mean?
You're going to see. Sorry, forgot a letter.
Slobs.
My Lord, I cannot spell today.
Slob.
When we talk about inverses, you all see me do this thing a lot. Why do I do this?
Flip it around.
We're flipping it. So in order to be an opposite inverse, we're going to change the sign and then we're going to flip it. So if it is, I'm going to say original slope and perpendicular slope. Now, here is another thing that you need to know. What this symbol right here means. That means perpendicular. So this dude right here means perpendicular. All day, every day. Merry Christmas. So let's talk about an original slope. What if you had, let's say, 3/4 is your original slope? Okay, change the sign. Is this positive or negative?
Positive. Negative.
So it's going to be, now flip it. Flip it. So we're changing the sign and we're flipping it. Here's where students get stuck. What if it's -2? Flip it.
Positive 1/2.
There you go. It would be 1/2. We changed the sign and flipped it. Any whole number is always over
1.
Oh no. So in order to flip it, you actually got to move it. It can't stay in the numerator the whole time. Why? Why that face?
Why would it just be 1
Excuse me, what?
Why would it just be 2?
What is 2 in a fraction?
2 over 1.
Flip it. Whole number, in order to turn it into a fraction, you got to put it over 1.
So you just change negative to positive and
That is correct. So what if it's -5/3? What is our new slope?
3/5.
There you go. You got this. Change the sign, flip it. That's the rule. And again, I'm going to warn you, this is going to follow you all the way into geometry as well as pre-calculus. Quit doing that with the chair. Put it down. Thank you. Don't kick the camera. Thank you. So, you're going to have to know all of this. You're going to have to prove that things are perpendicular based on slopes. Okay, so now, where does this come into play with what we're dealing with today? So this is our example.
How do you use like all of that space? I did that.
This does not look any different than what you just did with parallel. It's just that the slope is going to be different. We still have a line that we've got to be perpendicular to, and they give you a... Again, I feel like I'm talking to myself today. So you have a point. Do we have a slope? So what form are we going to use? So if you're a step person, let's go step 1. We're going to find original slope. Then we're going to change the sign and flip. So what is the original slope in the line that they gave you? 1/4. So here's our original slope. What's the new slope?
4 over 1.
Whoa.
-4.
There you go. -4. Because we got to flip it and change the sign. Okay, step number 2. What form are we going to use? Point, slope. What is point, slope form?
I think I'm gonna have to erase all of this.
Perfect. I got a slope. I got a point. What do I do with the point? I always tell you to label. So he is my X1. He is my Y1. Can I take these 3 pieces and put them down here? Yes. So this will be Y minus. Y1 is 1, so I'm going to stick that there. Equals new slope, -4, times the quantity X minus X1, which is 2. How pretty.
Wait, so it's just the same thing as
What you did in parallel? Absolutely.
flip.
The only thing you do is manipulate the slope. So now, how do I solve that? How about we do distributed property first? So y minus 1 equals -4x plus 8. Then we add 1, We get y equals -4x plus 9. If I want to see if these things are in fact perpendicular, can I punch this line and that line in my calculator?
Yep.
Okay, so let's do that, because I think in the calculator it looks a little wonky. So the first one is 1/4 x plus 3. The next one, clear, is -4x plus 9. I think it looks like a cross that looks like this that laid down. It's kind of the way that I describe what you see in your calculator for a perpendicular line. So it almost looks like it stood up like this and just laid straight down. So that's kind of what you're going to see in your screen. And again, is it going to look perfect? No. This technology, believe it or not, was developed in the 60s and 70s. And it has not really changed over the years. And TI-84, TI-83, they own like the lock on graphing calculators, which is pretty smart. So they don't necessarily have a reason to make it update, because computers do a lot of stuff, right? However, can you use a computer on your ACT?
No.
So you got to be able to use this and make it work.
Wait, they have more than 84, right?
Mm-hmm. They do, but you can only use 83, 84, or Inspire without the CAS on the ACT.
Do they have Monopoly?
A what?
Oh my gosh, Monopoly.
Yes, they have a monopoly on the market.
That's illegal.
They're pretty smart. Well, Casio exists, but I can't fix a Casio, which is why I don't like you to have them. Because what happens, like, you all walk up to me all the time and you go, my calculator won't do something. Can I fix it?
Yeah.
99% of the time, yes. Casio, I can't even figure out how to graph on that thing, but if we all have the same thing, works a whole lot easier. And this is pretty much the most used everywhere. Okay, clear as mud?
Yes.
Yes.
Sweet, let's talk about your second assignment.
Woo!
Open your book, 2-page.
Eventually.
243 again. This is 23 through 28. Make sure your computer is here in class whenever you get here tomorrow. We're going to have to do a CBM, and then we're going to do a quiz review because we're going to have a quiz on Friday.